Yeah, good afternoon, everyone. I think I got instruction to start now. I think my name is Pius Owolawe. I'm the head of the Department for Computer System Engineering. And my background is in physics electronics, my first degree, my master's and PhD in electronics engineering from University of KwaZulu-Natal, and also doing law with UNISA and machine learning with Texas University in the US. And I have several certifications in Cisco's, Microsoft, CWNA, and those stuffs. And what I'm going to speak about is on the area of Internet of Things, just to a little bit motivate you around the cutting edge technology, which we term to be Internet of Things. Having said that, we can dive into the topic of the day, which is basically the motivations around it, the genesis and the definitions of IoT, the Internet of Things element, the IoT applications, the past and the present project that I've embarked on, and the Internet of Things architecture. What architectures do we have there? The IoT frameworks and the IoT industrial platform, and what are the research challenges that we have there, and a few references for you to play with. Now, whatever motivates the areas of research should be the current challenge that we have now. Now, if nothing is challenging you, I don't see reason why you should do research at all. You don't often do what people have done. You do something that people have not laid their hands on, or they've not perfected in terms of research. Just to motivate you that how the future job probably going to look like, not to demoralize you, but to give you the pictures of what probably going to be the future job. I simply say that today's research is basically today's job and the future job. Therefore, when you do research, have at the back of your mind, how do you translate your knowledge into a valuable economy of values, or values something with respect to what you want to do. Now, it has been proven that, and this is the year that we said about 22% of computer job growth is expected in 2020. And we expect to connect about 7 billion of people and 7 trillion of things by 2030. And that is speaking so much in terms of what is the economy of the world is probably going to look like when we try to connect 7 billion of people and 7 trillion of things by 2030. That means it's going to generate a new economy framework and paradigms as a whole. Because I am sure if I can bring it down to your level today, if I ask how many people has device that is connected to the internet, average of 3 or 4 or 5 devices that you have that is connected to the internet by now. That means by the time we hit 7 billion of people by 2030, that average of people probably going to have about 5 or 6 devices already connected. And that means it's a new business paradigms as a whole. But let's look at the job that probably going to disappear on the face of the earth very soon. A farmer, ranchers, and other agricultural managers will disappear because some of them will be automated, basically. The postal services will disappear very soon. The carrier and the clerk, we might not see them anymore. The swing machine operator, the switch box operator, the fast food cooks, the agricultural workers, the data entry carers, and word processors and typists, we might not see them anymore. The fire clerk are possibly not going to be around. The petrol pump attendants and operators, the loan interviewers, and the clerk might go in extinction very soon. But what are the future jobs look like, which I expect you to be looking at? The area of artificial intelligence and machine learning is actually going to dominate the next future economy, which requires some of other devices like Internet of Things connecting with this. This is probably going to be the father of the economy of the future. And as a result of that, it's a good driver in the whole holistic job of the future, for example. The Internet of Things also will take a lot of part in the future work and the future research as well, where virtually sensors and all your wearable will be able to be connected to the internet. Probably your cloud will be connected to the internet as well. Therefore, your mobile, the social internet platform are the future job. The blockchain are very good future job. Big data, the automation, the robotic, the massive media, where we talk about your virtual reality, your mixed reality, and all 360-degree reality, all those things comes to being there. The gaming and all those stuff will come to being. Therefore, the mobile technology will also change in terms of infrastructure and the network, kind of what you have, like your SDN, for example, your soft-defined network that you have. Therefore, the cloud computing also, which is taking a lot of wave now. In Australia, I realized that now about almost 50 jobs that was highly paid this year came from the cloud computing, alone, and data science alone this year. That means the rate in which is growing now, and in America they are short of data scientists and the machine learning expert now in terms of the number they need in their system. The 3D and additive technology will also take a very good important aspect, because now we have a 3D printing house now. We have a 3D Nike techie now that we have. Therefore, they're probably going to take a lot of space in the future job. The customer journey experience also will come to being, a collaborative technology, the nanotechnology, the advanced material, the new touch interface, the wireless power, possibly. There's a lot of research going on the wireless power. That means we don't need to connect cable to cable anymore. We can transmit them. The only problem there is because it has to be transmitted at a very low frequency, and which can only carry a little bit power along the line. The proximity technology also is coming to play, and the new screen technology also is also going to come to play, in the new work of life that we are going to enter new dispensation. Therefore, whenever you want to do research, you do something that will either provoke your thinking, or provoke your economy thinking, or provoke the economy of the country, or solve the problem that is around our continent as a whole. Now, what are we saying? We're saying this: the current status and the future prospect of the IoT, how does it look like? We say by 2003, the world population is around 6.3 billion. By 2020, we expect the number of population of the world to be 7.6 billion in total. And that means that by 2003, we have about 500 millions of devices that's connected. By 2020, we expect 50 billion of devices to be connected. And that is saying something to all of us in terms of the research and in terms of economy generations that we expect overall. Now, what are we saying? We're saying that the connected device per person here is about 0.08. That was in 2003. Per person by 2020, we expect average of 6.58 of devices that needs to be used by only one person and connected to the internet. If I ask you now, you have phone, you have iPad, you have a wearable watch, you have so many things that is connected to the internet. That's what we are talking about here. By 2020, we expect the average to be 6.58 devices connected. Now, who is going to service those devices? Who's going to work on it? Who's going to improve on it? Who's going to do a lot of advanced thinking on that? It's you. Therefore, that is the area where things are coming. Therefore, when you want to do research, make sure that you do within the domain that it's needed for the future. Now, what happens when 50 billions of people are connected? We're going to have a terrible environment as a whole, which we're probably going to call an industrial internet of things, which is going to combine everyone, the system, the industry, the machines to machine. Everything all together will be connected together with industrial internet as a whole. Now, when you look at this, we realize in terms of the penetrations of the network, we say by 2.7 is expected in terms of penetration by 2020. And this is amazing things that we are expecting with respect to the broadband and other platform of technology that will dominate the industry. Now, let's look at the industry that seems to going to benefit from this particular Internet of Things. The leading one that we can see here probably is the oil and gas industry. They're going to invest almost $9 billion in that place. That means if people say they don't have a job, you just have to reskill yourself. People read every time. For me, I don't stop reading. I make sure that at least in a year or 2 years, I make sure that I do one degree or the other every year so that I improve and I'm able to meet up to the target. For example, now, I'm working with, for example, now I'm studying, for example, now I decided to take a new degree with the University of Texas in the US to study machine learning and AI as a whole, so that I have a qualification in machine learning as a whole, how those artificial intelligence comes in. Therefore, the industry of oil and gas is going to spend something about $9 billion in the areas of the IoT alone. And talk less about when you look at the area of the health, for example, because we want to make sure that our patients are properly monitored when you put them on any system at all, so that we can monitor the pulses, we can monitor your heartbeat and everything. It's taking about 63-something billion that they're going to invest on that particular area. These are the key areas that where we expect a lot of Internet of Things dominating that particular area. You're talking about aviation, you're talking about power, you're talking about healthcare, you're talking about rail, you're talking about oil and gas. Those are the areas that we expect that IoT will take place. Now, let's look at the genesis of it. Where does it come from? I want to look at it from the point of the internet, from the beginning of internet as a whole. When we look at it from the point of internet, all of us were used to our hypertext markup language, which is HTML, for example. And that's what we simply term to be your Web 1.0. That's your hypertext. And in that case, it's just about interacting with document alone. Document does not interact with you. Under the Web 2.0, where we enable the user interaction basically with the network, with the social platform, and the content that you have on the web. That's your Web 2.0. Under the Web 3.0, that's where we call a semantic web. A semantic web is more of interactive web that you have, that you interact with. And that's what you see. And that's exactly what gave back to the IoT, where we'll be able to connect devices through the sensor to the internet and interact with the owner of it. Then it becomes Internet of Things. And this kind of a seamless connectivity and anytime, anywhere, and that is what this particular IoT simply typify and what it means. But the backbone on it is basically you rely on the Web 3.0. And that is where the technology of the IoT basically starts. Okay, let's look at the part of it. The part of it is that we said the Internet of Things. It has different names. I don't know the name you know it to be, but the popular name that people call it is Internet of Things. Also, we have what we call IoT, which is Industrial Internet of Things. Then we also have what we call machine to machine, which is simply you have one device A and device B and they speak to each other through internet. Then we have what we call COT, which is a cloud of things. Or we have what we call WOP, which is a web of things. It depends on each of them have their own meaning, and people tend to misuse them the way they want to use them. But for me, I always prefer the Internet of Everything. Because the Internet of Everything, it involves your device, not Internet of Things alone. Because Internet of Things means a device communicating with internet. That is not living thing communicating with internet. But when you say Internet of Everything, both people internet connecting with people, the thing connecting with internet, and whatsoever you connect with internet can simply be captioned under this Internet of Everything. How we rather go for Internet of Everything than just sitting down on Internet of Things. And there are several standard organizations who have coined their own names for the Internet of Things. A very good example is European Standard Organization. They call their own Internet of Things different thing. Then we have Internet Engineering Task Force. They call it a different name. Then we have OASIS as well, which actually call the Internet of Things different. These are the body that basically create a standard around the Internet of Things. Okay. Now, when we say Internet of Everything, for example, what are we talking about? The Internet of Everything has a comprehensive meaning than IoT, like I've explained to you. A very good example is the one that the Cisco Vision actually came up with, which is Internet of Everything, which is a 4-pillar of a building block of, number 1, the people, number 2, the thing, number 3, the data, and number 4, the process. Therefore, they are able to combine those particular 4 elements together to come up with what we call Internet of Things. The ordinary definition of Internet of Things only involve the things only before. But now, the Internet of Everything, it involves the thing, it involves the data, it involves the process, and also include the people. That is why your wearable wristwatch, you can't call it directly Internet of Things if you don't define it under these definitions. But you call it Internet of Things because it interacts with you. It gets your body temperature, it gets everything. Then it becomes Internet of Everything. And that's what we simply mean. Let's look at it from a broader sense also. We have the entire system, the ecosystem of everything around us. For example, we have your laptop, you have your farm, you have your garden, you have your cart, you have everything. Now, all these together are speaking to you as a person. And these actually come with interaction with you as human being. Then we have what we call Internet of People. There is a new thing now we coin out with Highland in a new research. We call it Space 4.0. Now, in the first Space 4.0's new project we want to do is to be able to explore what goes on the ground. Then can we translate everything that goes on the ground into the space? For example, you have a transport. Instead of having a transport, you have a vehicle in the space. Therefore, you create not only an aeroplane alone, but we create all the devices. We create a network in the cloud. We do so many things. But everything we term them to be 4.0, Space 4.0, because we want to conglomerate all the technology in one cloud. But this is a new project now that's sponsored by the European Union. But when you look at this as a whole, you find that all the devices, your rain, your weather, everything is speaking to you. And that is exactly what is termed to be Internet of Everything, not Internet of Things alone. Let's see two common definitions that you can simply find cheaply around you. The first definition is the one by the Standard Organization. They said the embedding short-range mobile transceiver into a wide array of additional gadgets and everyday items, enabling new forms of communication between people, things, and between things themselves. Between people, between things, and between things themselves. Now let's look at Wikipedia kind of definition. It defines it as the Internet of Things, also called the Internet of Object. That's amazing. Not Internet of Things, Internet of Object. That's another definition. Therefore, you are not losing the definition when you say Internet of Things. Okay, now it refers to a wireless network between the object. Usually the network will be wireless and self-configuring. I love this, self-configuring. And that is what you don't get in ordinary static system. You get that in a dynamic system. It's a self-configuring. Now, I have three-dimensional way to actually define it. The three-dimensional way is to look at the anytime connections, any place connections, and anything connections. That's a three-dimensional way to define what is Internet of Things is all about. The anytime connection, any place connections, and anything connections. And you can see all the property below each of them are almost similar. On the move, you find it on the move here. Between the PC, you find it there. Therefore, it's a kind of a three-dimensional approach to look at it from the anytime, any place connection, anything connection, and exactly that's what the Internet of Things is all about. Therefore, if you are thinking of it at all, just think at it very well. Now let's look at the role player. Who are the role players in this Internet of Things? The first person is Intel. We spend so much of the money, is about 72% of contribution to the Internet of Things. Intel, most of the hardware you find at the platform of Internet of Things are being made by the Intel. And a very good one, you have all other ones that are there. But this is where we work. We work with PTC, basically. We have 85 licenses from PTC. We are the only one in the whole Africa who has this platform, where we have the IoT platform, the software, the architecture, and that's the PTC. It was being sponsored. It's almost half of about 0.8 million of resources that we put there that we work with. There are other role players like Cisco, Microsoft, Google, and all those things. The popular technologies that we have in the world, they are actually investing in it. Let's look at the applications of it. The application ranges from the smart home, your wearable, your smart city, like the president said, but I don't know how he's going to do it, but he promised that he's going to have a smart city. Now, there's no way you have a smart city when you only have a smart city in Lanserian, for example, what happened to the other places? Then it's no more smart again. It's both smart and whatever, analog and digital anyway. But you will see that. But it's a smart city, basically. Now, we also have a smart grid, where your grid is basically intelligent control. Your power system, your platform, everything is basically intelligent control. Then we have what we call industrial Internet of Things, where you are in your room and manage a kind of a multi-million plant. You stay in your room, put on your VR and control everything within the room, and you control the entire plant. That's about almost 300 kilometers within your room as a manager. Therefore, this play a kind of a role from that place. Connected car. It tells you what is the health state of your car. It gives you all the information even before you enter the car. You know, that's where you get all those things. Connected health. If your child goes to school, for example, the body temperature suddenly jump up, then there's a trigger that says, no, you know what, temperature is going up. Probably it's going to have fever. But you drop your child in school, but something intelligently manages your fear as a father or as a mother. Therefore, absent father like us is no more necessary anymore. Therefore, you have something like that are available. The smart retailer. The smart retailer in the sense that you want to go and shop, you know, for example, instead of getting embarrassment, you take the item 2. You know, people that take about 5 or 10 items, they put them in the basket, they're so proud with it, they will it. When they get to the cashier, they take number 1, then they swap the card. It bounces back. They swap second time. Yeah. And then they say, okay, can you take this one out? Can you take this one out so that I can swap? Now, intelligently, when you have your retailer, immediately you drop the first item. It goes straight into your bank account. You say, no, you have 500. No, you don't take bread, because when you had bread, it's about 500. Then you go confidently to the retailer and say, yeah, my item. And you put your hand in the pocket and say, no, swap for me, because you know exactly what is in the car. Because the card is connected to the bread. The bread is connected to everything. You can measure your gauge as you go. And that's what Internet of Things will do for you. It's called Smart Retailer System. Also, a kind of a smart retailer in the sense that it can recommend certain items for you. You like buying techie, maybe you like buying certain clothes. Then you say, no, you know what, there's a sale somewhere. Why not try this? It's yellow or pink. It gets what you might like a recommender system. Therefore, you get those things right here in this kind of way. The smart supply chain as well, you know, where you can monitor when you dispatch an item, and when the owner receives it. And you can even experience a customer experience from there. How is the customer feeling about what you deliver? You know, it can give you the feeling about it. Then we have what we call smart farming. I love this because this is my favorite. Smart farming. Therefore, you can have that where you have your water, your supply food. You take all those workers on the farm off, and you manage when the water is supposed to drop for the chicken house have a temperature monitor. You do everything without you being there. And that is what it's going to happen to us when it comes to that time of Internet of Things. It's a quite interesting area of specialization, which have a lot of prospect with respect to what we have. If you look at our country as a whole, we can only mention about 5 or 6 companies that are into this particular business in a big terms, you know, especially Internet of Things. Now, let's look at the Internet of Things. What are the elements? The element of Internet of Things. For example, remember I mentioned sensor to you, which, for example, is the identifications of the item is the key. And it does this via the sensing system, which is a sensor. Then it has a platform of communication, the broadband, all those things, which does the communication. Then, not only that, there's also a computational aspect to build up intelligence on what should I do, what decision should I make. That's your computational aspect. Then we have the service, which gives back the feedback, and we have what we call a kind of a semantic, you know, where you'll be able to harness the advantage or the value of it. Now, if you look at this, for example, this is where you have your RFID, for example. You have your signature here. You have your identification. Then your identification basically is being managed by your sensor. Your sensor takes some information. Then it goes down to your data processing and application of intelligence. Then it goes through your 4G or 5G or 10G, whichever. Then it goes communication. Then it goes down into your service to say the heart pulse of that person is beeping too much. He might die very soon. Then you get that information from there. Now, Those are the intelligence that you might get possibly from that. Now, let's dive a little bit deeper into the element of Internet of Things. Now, when we talk about identifications is basically, it plays an important part in matching services and naming. Some example of this method that are used in Internet of Things are what we call ubiquitous code and electronic product code. This is called basically EPC. Then we have the other area which basically work on the public internet and protocol aspect of it. Then we move down into the sensing. In other words, most of the device, for example, there is a project now we begin to do with the mining. What happened is that in the mining, the water that came out, that's coming from the mining place, are not healthy, not very good, But we want to measure the content of it, and we don't want to go to mining Upamalanga and all those things anymore. We want them to put the water into a smart bottle. We put the water into a smart bottle, we put different sensors there. We take all the reading, we transfer that reading down here, we send it into the system to process the reading and predict and say this water has a certain level of calcium, certain level of iron, certain level of zinc, therefore it's not healthy for people to drink. Therefore, we use that, and it simply contains a simple RFID, which is very tiny, you won't even know. Therefore, if you want to track your wife, you can just keep it in a bag. Then you'll be able to track her. But now you have that. Okay. Now, the other one is the sensing. Okay. This element of IoT means to receive information from various selected objects and then send the information to the data center and database and data warehouse. That's what the sensing normally do, basically, to do. Then the other thing is, other platform that makes sense is the communication aspect. Remember, this is where you use your Bluetooth, your Wi-Fi, your long-term evolution with your LTE advanced and all those stuff. You use them, all your broadband, sit down under the communication. The computational aspect is where you use different processing units, your microprocessor, your microcontroller, your chip, your Arduino, whatever, your Raspberry Pi, your bigger ball and all those things. You use them here basically to develop that particular computational aspect where you put your embedded software to drive the whole game. Then the service as well. Let's look at it from the point of service. Okay. Now we have a different major, I think 3 or 4 categories of services with IoT group. The first category is the service that does the identity related service. These are the main services which are needed for other type of services. Each application has a map real object into the virtual one. While the second category basically look at the service of information aggregation together. It just do information aggregation. It collect the data that you save, then it aggregate them together to give probably a better meaning. Then you have third category where you have the service collaborative aware services. It utilizes the acquired data to make a specific decision for what you've done. And the fourth category is a service of ubiquitous service. It offers the above service to everyone. You make it available to everyone. Where semantic is an IoT. In IoT simply means that semantic is capable to grab information smartly and to provide the mandatory service. It grabs the information. For example, if I have a certain device here, it can take the measurement of the temperature of everybody, possibly, and say there's somebody temperature here is more than the average of human being. Probably it's a different human being. Okay, but you get that. It can do all those things that you have there. Now, let's look at the technology of IoT. Now, remember this have to sit on certain technology, for example. And the technology that I'm talking about is the connectivity technology that I'm talking about. They tends to rely more. Remember, it's an internet-driven technology, if you understand that. But there are a few technologies that we will look at that this particular IoT are basically, they work around. And I'm going to classify them into the short range, which is frequency dependent, into short range, into wide range. Now, let's start with short range kind of wireless communication that we have. A very good example is your Bluetooth that you have on your laptop that connect to each other when you want to download the movie. And this technology is simply called a personal area network, PAN. Then the second one is what we call light fidelity. This is not popular, you don't hear that oftentimes, but it's a light fidelity which basically based on the simple optical light. The simple optical light speaking to each other at a very shorter range. Therefore, they carry more in terms of the bandwidth and they are bidirectional type. They can speak to each other like a two-way phone. Therefore, they call it LiFi. It's an entirely network wireless communication technology, very high speed, and bidirectional technology, which is very much same as your Wi-Fi. Okay, but the problem there is what we call the alignment. If the alignment of the light doesn't see each other, you lose the entire information, which is not very common with the case of the Wi-Fi. Whereas Wi-Fi is a composition of what? The visible light. We have another one technology called the near-field communication. In the near-field communication, the technology basically need what we call a magnetic field induction. You know, I'm sure that you remember magnetic field when you are in high school. You remember magnetic field? Even if you have ordinary bar magnet, that's what we call magnetic field, okay? Now, it is electromagnetic field in the sense that when the field generates electricity from the interaction, you call it electromagnetic field, okay? What you basically have, where you have a two polarity, where you have your vertical polarity to be field and the other polarity to be electric field. Then you interact them together, it becomes electromagnetic field. Now, you have the near field communication here, which actually is almost need a magnetic field induction to facilitate the connectivity. Basically, they use the flux of the magnet to be able to facilitate the communication between the two objects, and that's what we call the near-field technology. It's not a popular technology that we have because of some issue and some challenges that we have in deploying it. Then a common one that you are used to, which everybody is used to now, is your quick response code and barcode. Like my father, who came from the farm, asked me one day, we wanted to go through the airport, and he was saying, "Oh, where's your ticket?" I said, "Papa, there's no ticket now." Then when I got there, I took the phone, I just swapped it. "Ah, your phone is a ticket." I said, "Papa, it's a barcode." Then I show him, say, "What is this?" What is this? I said, "Papa, there is thousands of information here." He said, "Can I see it?" I said, "You are not privileged to see it. You have to go to school." Okay. Yeah. Then we have what we call quick response code, and we also have what we call a barcode. Okay, the two are basically, you use them also for connectivities, which is very, very interesting. Then the popular one that you are used to is what we call radio frequency identification, RFID, which everybody is using. Basically, you use it to tag, you use it for your gate, you use it for whatever. Even you can use it for the animal identifications. You know, if you hide it inside your cow, if they are stealing your cow, you just keep it, open the skin of the animal, put it there, and allow it to monitor. It's a very good example is this one, where you can plant it in your skin. Therefore, it's quite going to be easy for people not to miss again anymore. We should be able to find anyone that is missing. And if anybody is walking around and you want to know where they are, all you have to do, you just plant this one, you plant it right into their whatever. You see, it's here. Just, it's not something very okay. Yeah. You put it here. You can even go, instead of you taking your card and they stab you instead of the car. They don't even know where this, you just keep it, you go to the ATM, you swap it, the money comes out. Except if they know that, then they cut the finger and take it and go and swap it. But if you hide it somewhere, if you hide it here, or you get to the ATM, or you hide it, you all go to the, then you do that, then you take the money out. Okay, yeah. Those are things that I think it's possible, which is going to be possible in the nearest future that we're going to experience. The Wi-Fi, which are used to, is also part of the technology platform. The other one is what we call Z-Wave. There's another technology we simply call Z-Wave. It's used in a smart home. A lot of Z-Wave technology is used popularly in a smart home because it's a very short range kind of a connection, which is almost transfer up to about 100 kilobit per second. And most of the data they transfer in the home connections is not even up to that particular level if you want to do in terms of any communication. Now, we go to what we call the medium range wireless communication. Wireless connectivities, rather. Now, under that is where we have our long-term evolution, which is our LT that you are used to, that Vodacom is selling to you. Then we have another one, which is called the long-range wireless, where we have a low-power wide area network, where this is also not very popular, but so many technology is using it. V2 to V, which is vehicle to vehicle, is using it. Machine to machine are using that kind of platform of technology. Another one that we're working on is what we call LoRa. We work with LoRa. This is a very powerful mini kind of wireless connectivities, which can cover a very long, big range instead of a short range that we have. And we use it a lot, in so many areas of application, especially when it comes to the IoT applications. Then we have a long range wireless, where you have your visa, your VSAT. It's not popular here, but many African countries, they have what you call, they use what you call VSAT to communicate, to do their broadband, especially in the rural area, where you basically connect it to the satellite, then satellite give you a receiver, then you can actually have your own broadband company by having a VSAT, okay? A very good example is your Agilat or Gilat or something like that, which is for Europe, that cover the footprint of the Europe as a whole. Now, we have this, which is your satellite communicating. That's your VSAT basically, and your VSAT give provide the kind of internet to other area of the rural area that you can have. Then we have the wire-based technology, where you have your internet, where you have your Ethernet, you have your fiber optics, you have power line communications, you have optical fiber, you have free space optical communication, you have all those things that simply sitting down under them. Yeah, what I've done here basically is to look at the IoT applications. A very good example is a smart home. If you click that, you see how the smart home basically operates. I just got some YouTube type of how the smart home actually basically look like. Then I also have what you call a wearable type of IoT, and I'm sure a lot of you are using this now. It's just like I'm not fortunate to have one, but you have your UP4, UP3, UP2, which have a lot of very nice advantage to really monitor your earth state, because most of us are a little bit reckless when it comes to our earth state. Maybe because we have mortuary insurance possibly that will take care of us if we die. But those things will help us a lot. Then we have a smart city that our president is talking about, where everybody will be basically connected, okay? And everything will be connected, the road will be connected, every power will be connected, everything will be connected. Now, to be honest with you, I always say this, I don't know how that will solve the problem of hunger. I don't know. How can it replace food? No, the basic thing we need in Africa basically is food, shelter. If you can solve that problem for us, that should be enough. We wait when the death will come and take us. Then we'll go back. We'll go back to where we come from. Okay, now we look at that smart city, as our president said, which is basically is a lot of investment. It's a huge, huge investment, where you connect everything around you to the internet. Now you don't even have ESCOM. How are you going to power the internet? Isn't we go this way? We want something this way. We don't even have this. We want this. I don't know how we reason. But that's typical of Africa anyway. We like to do things that they are doing, everywhere in the world without even asking why are they doing it, what infrastructure do they have in place, to do it. If you go out ordinarily, if you drive from here to Victoria North, just count how many robots are active, especially on Saturday stroke Friday, when we have good people who have a nice time outside and just look at the pole that this thing needs to be replaced. They just hit their car with it because they are under a certain level of another word. But the point is, all the basic things is not even there. How do you now put a high level technology? It's just like you say that you create drones that do delivery, which they do easily in America. And I think Rwanda now they are doing that. Now, by the time it's flying around here, the tree there, the tree here, we can't crush the whole thing. And if you come from where I come from, which is Durban, especially in Mlazi area, they just see that this thing is carrying a package, especially if it's a Pixar one. If you carry a package and it's going like that, the boys there just look at it. They just stretch the long tree and say, hey, this side, come down here. If you don't want to come down mechanically, you come down manually. They just took it down and take the prayer and leave the clothes to go away. Now, the environment alone have to be designed to meet the technology. Therefore, mentioning smart city, I think the president just wants to say something and goes into yeah. But he said that he has so many dreams. Yeah. Okay. Now, let's look at the health application. Okay, let's quickly look at the health application aspect of it. The health application is that it is, as we've seen before, it's very useful because I think last semester we were able to develop a kind of way you just wear it, you measure your heartbeat, you measure your body temperature, and basically give a possible intelligence to you that your body is not okay, that, you know, then we had a little bit intelligent with it to predict what your body environment, it give you some stuff, which is very good. You know, then the smart parking, I think this is all available now, which can actually give you information from home. That if you go to this mall, you only have the basement parking, you have two left, and all those things. You can do pre-parking from home, you can do all those things. This is the advantage of the Internet of Things that you see. Then also we have the vehicle-to-vehicle applications now, where everybody is connected, the vehicle is connected. This, because of autonomous vehicle, this can speak to this to say that please avoid, because very soon now we don't need driver anymore. But it can't happen in Africa easily. We have a lot of serious drinkers around. Therefore, the car can also get drunk if a drinker is inside the car. Therefore, the road is something that, you know, I'm not sure, you know this new Audi they are selling, which when you enter the grapho, it gives noise and you know, it's automated. You can take your hand from the steering. That's a very expensive car, is it? Yeah, but we have it now. One of my friends bought that car. Now he drove that car to a village in other KZN. By the time the car entered the grapho, he just shut the power. Boom. Then he was calling the Audi. Audi, the car has stopped working. Now the Audi said, where are you? He said, I'm on a graph. He doesn't recognize that one. It's meant for the Western world. Now, he brought it and took it to another KZN. You can see the environment against the technology. It doesn't work. It doesn't work at all. Therefore, it's only the Audi who solved that guy problem. Now, how do you drive autonomous vehicle in a road that the driver license is maybe got it through bribe? And now you drive autonomous vehicle against the manual. And here, if you're really, you know, have you ever been a taxi driver? When they drive, those people doesn't follow rules. You see, now you drive a control car in uncontrolled environment. Those are the things that is affecting us not to grow quickly. But it's not good to be using their terminology. You see, one day I was in MIT in the States. I was working with one professor there. I saw this man was opening, you know, this window 95. You know that screen, window 95. I saw this professor was using window 95. I asked this guy, what are you doing with window 95? He said, excuse me, what wrong? I said, what wrong? But here where I came from, one Microsoft released a new version where we cancel every operating system shut down, we upgrade. Upgrade for what? You have not even finished Windows 95. You have not exploited Windows 95. You are going to Windows 12. Why? I feel we just want to waste money. That's the way I always feel. Here, even in this university, we've given some people computer. They cannot even use Excel. Now you are giving them another platform. Why are you wasting people's money? But you can see a sense in that guy. And he told me, I haven't finished using Windows 95. Let me exploit it. That is in MIT. Whereas here with us, immediately the manager, they say, Windows has released another one. There's a new computer. He come to the office, his plan is, can you remove all the computer? And nothing wrong with that computer, for heaven's sake. Remove all of them so that I can buy a new computer. For who? Then they pack everything and drop it in the junk. And that's the end. And that's the way we waste resources. That's where we waste money. And that is why the resources cannot evenly distributed across to everybody. And if you apply your mind to things, we'll be able to manage the little resources that we have in Africa. And we have so much of resources in Africa. I will tell you one stupid country that's very popular, is a Nigerian one. Very stupid place. Now, they are the third largest oil producing in the world. But do you know that oil is not processed in Nigeria? They take vessel, carry the oil, go to overseas, process the petrol, bring it back and sell it times 10 price of what they take the crude oil. Are you telling me there's no chemical engineer in that country who can just put the test tube together and process crude oil and bring up petrol? It's not there. Okay. And that is who we are. That's who we are. We're wrong thinkers, and we must think in a very right way now. We're wrong thinkers. We need to think in a very good way that will solve our problem. Africa is the only continent in the world. You take a millicorn, just a one seed, you throw it on the ground. You don't cultivate it, you don't put fertilizer, you don't put water. When you come there after 3 months, you see a cob of maize, complete, and you take it without you doing what? It's only Africa you have that. Ask them in Arab, in Saudi Arabia, ask them in Israel, ask them there. They use a lot of thinking to make one orange to grow from the ground. It's only Africa. You throw a seed on the floor. Nothing you do afterward, you get 100 equivalent of the seed here without doing any work. And we don't care. And we are the most wretched continent in the world. Nigeria has almost 65 mineral resources alone. 65 mineral resources. And people go home, go to bed without food. It's sad, isn't it? It is. Yeah, but anyway, just to motivate you. So that when you do the research that solves our problem. In this Shoshanguve as well, so that you solve our problem.
So, Doctor, maybe it's not because you do not have thinkers. We have thinkers, but the platform given to thinkers to execute what they have in mind.
No, you are very wrong. And you know the reason why you are very wrong is that who selected on thinkers? Who put his hand on the paper and say, I'm going to select this guy who doesn't think. This is me too. It's a feedback system. It's a feedback system. And you know, it doesn't require a thinker to select a thinker. The problem with us, and it's simple, we don't practice the politics that solve problems. We practice the politics that kill. Matches, money, bribery, that's the politics we practice. And it has a returns. You see, that kind of politics has a return. It's only Trump in the whole history of America who became president without being the corner or corridor of power, who trained. Every president in America was trained before they become president. Don't think leadership is a gift. It's wrong notions. Leaders are trained. When you become a president of America, they sit you down. You know this Arabian, this is how to behave with them. You see that Nigerian, this is how to behave with them. You see these people, they train you what to do. Even if it's against your will, you must do it that way. That is what we call a constructive environment where thinkers think. But here, you don't say that we don't have thinkers. We do. We do. The best political agenda in the world, that is the best, is ANC one. Where you see, when you read that thing, you feel it should be the best in the world. Where a lot of thinking went through. But how many are executed and how are they done? It's not about the thinker that will solve the problem of Africa. It's about all of us taking responsibility about solving the problem of Africa. We are not people that are supposed to suffer. That's what I told the Lesotho government. We shouldn't be people that will suffer for anything in life. There's no African country that doesn't have mineral resources. There is none. I haven't seen any. By geolocations alone, Africa has everything because it's in the base. Most of the resources that flow from the sea comes down to the base, and we position ourselves in that direction, that base. The Therefore, why should we suffer? But we suffer because we are stupid. Because somebody take crude oil in your yard, he take it to overseas, he process it for you. He bought it 5 rand. By the time he's coming back, he's selling it 50 rand. Can't you just put your mind in what is happening? But this is our time, and our time in the sense that we should express our knowledge to solve our problem, which I think that your group or your set should try to set. Let's see what we've done so far in the area of the past and the present project. Yeah, these are my first team that I have when it comes to IoT. These are wonderful guys that I have. We are the only university that was invited by MTN on IoT. All other people are industry, like GE, like top industry. We are the only institution invited for the IoT competition in that place. That's why I took the picture with them, because then it was something that I'm so proud of, you know. And we developed a lot of stuff that actually give solution. We have what we call a smart home demonstrated with a complete IoT, everything automated. We just make a prototype of it, how a home can be automated from your bathroom, from your lounge, from everywhere. We just create a demo of that. Then how do you IoT the entire place? Now, we also are the first university who has the combinations of many companies like OneWorks, which are IoT company, PTC, ThinkSpeaks is one of, ThinkWorks is one of these platform for IoT. We are the one who have that in the whole, let's say, I won't be so proud to say the whole Africa possibly, who subscribe to that. And this is almost almost 1 million project that they gave us to do. And you can see all the company, and this is the CEO, you know, and that is also the manager, and these are the entire team that make up that team. Now, what have we done? We've done this. We've done something on IoT-driven drones, wildlife monitoring system, IoT monitoring system for home automation, IoT-based human detections, and repositioning system for retail store. We've done IoT-based mobile robotic for coal mine surveillance, IoT-based intelligent car management system, IoT-based attendance monitoring system using the fingerprint and on Raspberry Pi. Then we've done IoT-based 3D printing as well. We developed that where we monitor the health-wise of the 3D printing. Then we've done IoT-based autonomous poultry farm monitoring system where we try to monitor the behavior, the environment of chicken in terms of temperature, humidity, and all those stuff, the lighting and everything. We're able to manage everything together to make sure that each chicken survives the life before they get to KFC. But fingerprint with IoT. We also did fingerprint with IoT-based electronic voting system, IoT-based car passenger monitoring system, proximity fingerprint, RFID attendance monitoring. We've done all these projects on IoT that relate to IoT. Those are things that we've done on that particular area. Let's look at the architecture. What is the Internet of Things architecture? How does it look like? The Internet of Things architecture basically consists of 3 layers. Okay, we have what we call the 3 layers, the 4 layers, and we have what we call 5 layers. Now, when we look at this as a whole, we look at the 3 layers of this in terms of application layer, which you are used to. We have network layer, which you are used to. Then we have what we call perception layer, where the sensor basically sit. Those are the 3 layers that we have. Then we look at it in terms of what are the devices that basically sit around that particular 3 layer. And that's why I put different tag, different sensor, everything within that particular domain. And a good example is your electronic product code, that EPC is also falling with that particular area of perceptions layer. That's what you can find in perception layer. All the sensors, all the RFID, all of them sit in that particular area. Where your network area basically consists of the area where most of your processing and data transfer and your intelligence are residing under the network layer. And your application layer or your process layer is where you basically have a kind of collection of data, and the identification and the control of the entire devices actually take place under the application layer, or you call it a process layer. Those are the 3 layers that we have. We also have layer, remember I started from 3 layers. We also have a 4-layer architecture, but 3-layer architecture is the basic architecture you can ever have. You can't go minimum of that in terms of your architecture. In other words, your architecture must consist of these 3 minimum whenever you want to work with IoT. But to make the IoT platform to be more robust, possibly you can go as far as a 4-layer, where you have your application layer, then you have your management service layer, you have your gateway and network, then you have your sensor connectivities. And this particular first layer, the layer one that you have here, the layer one you have here, the perception layer, is what basically termed to be your sensor connectivities layer that you have, where this gateway is your network layer. And oftentimes the application and the management layer service, they work hand in hand to make sure they have a seamless connections and similar behaviors when it comes to the applications of that. Now, let me quickly go to the 5 layers of it. Under the 5-layer architecture, we still have your perception layer, we have your transport layer, we have your processing layer, we have application layer, and now we have your business layer, where you put your firmware layer, where you can actually do more of applications and all those things under the business layer, and you can incorporate it. Let's look at IoT technology, which I've explained to you earlier on, which is your LoRa, your Sigfox, your CBB, and all those stuff, which basically work on that. Let's look at the framework. A simple framework that I so much love are this kind of framework of the edge direct to the tower, where you have your communications. Then we have the end node, where you have your CCTV camera, your bulb, all those things, they stay here. Now, then you have your connectivity, which can be your CBB and thread and all those things connecting to that. Then you have your gateway, which basically speak back into your cellular network, which is from here as well. Then you have all these AW, your Amazon, your Google, your Azure, your whatever. They sit down here as a cloud platform where you manage them. Then you look at your generics, system security. This layer might not be important, but it is important because if you connect under a very you need secure intelligence, you need that. Then you have some few applications that you can actually use. These are all the applications that are available to support this particular architecture. Then we see the applications. A very good example is your Alexa controlling everything in your house. Alexa, crack joke. Alexa, crack joke. Alexa, make me smile. Alexa will make you smile. Alexa, put on the TV. Alexa will do that. Maybe that will be Alexa. Alexa, can you kiss my wife on my behalf? Maybe Alexa will do that. But we are getting there now, because Alexa is tending to be very smart because of more data they are getting. Recently I asked the Alexa, please, my wife is not here, please sing for me. He said, do you want? Then he sang a romantic song, but I don't know. But Alexa does so many things for you, and that's where the application comes from. The MPU OS also, where you have a platform of operating system, the Linux, the Android, and all those things, the Android and all those, they work there. Then we have all that platform and the communication, which basically lie all together to form a IoT framework, and that's the IoT framework. Let's look at industry that are primed themselves in this business. A very good one is what we call GE Predix. It's a IoT platform which is also very popular. The Cisco also has joined the business as well. They call it Cisco IoT Cloud, which is also available. Then the IBM already, they were in the business long time ago. They call it IBM Watson IoT. Then this is the one that we are a member, which is a PTC ThingsWorks. Those are the 4 platforms that is very popular when you drive the IoT technology. We have this. This is where we work, PTC. I think I showed you their picture earlier on. And when you look at this as a whole, you can see what they've covered. They deal so much on the network connectivities, the fog computing, the data analytics, the security, everything is embedded with respect to Cisco IoT. But let me talk about our own, which is a PTC ThingsWorks. It's about 3 pillar technology that we have there. We have a core application enablement, we have connection service with device and the cloud adopters, then we have the edge connectivities using the edge microservers and edge. This is, we've used it for so many things in terms of what it can do. I think I will have come with so many pictures where they've used that platform, especially for farming management and all those stuff, where we save a lot of farmers a lot of money on watering their farms and all those things. Let's see some research challenges, because this is where you need to work. Okay, I'm not sure if I'm convincing you to join IoT to be able to do IoT stuff, but it might require some hardware knowledge from your side. Therefore, it might not be something that you can like. Now, let's look at the research challenges. One of the research challenges that we have there is a scalability. Scalability in the sense that when you have a massive devices, we are talking about 1 million devices. How do you intelligently manage them? That's a big problem, because this relates with the protocol control. And these actually have a lot of challenges how we manage them. Now, how do we now undo data that will be generated by 50 billion people and 50 billion devices that is probably going to come up by 2030? That's where your big data comes in. Okay, and some of you are doing big data. Now, move cloud service to edge of the network, which you simply call the fog computing, is a very useful computing cloud system that we expect to come on board when it comes to the IoT. Therefore, you can do some work on the fog computing. It's not popular, but it's a very good area to work on. Reducing of data to be stored in the sense that you carry out some processing of data and data storage. Because you notice that not all the data needs to be stored. Some data need to be processed and trim off. Therefore, there's a need for a lot of intelligence and a lot of work to be done, not to accept all the data, because not all the data are very, very useful, but by default, the system have to store them. The other area that is very crucial is the power consumptions of all these devices, especially the connectivity devices. There's a problem there. They chow so much power that people need to manage them. For example, if I want to monitor sharks or whales in Cape Town, for example, and I want to make sure that I want to know where they are, I want to know their health state, I want to know if they are bleeding and all those things, and I put all my devices around them, and they decide to travel to another island, to go and get another baby from that place, Now, indirectly, I'm not going to see them for about 5 or 6 months to come back to the source where I can take the device away from them and change the battery. Now, if they go with it, indirectly, I'm probably going to lose the data, and I'm going to lose the device, and I'm going to lose the information, which is more important than the device that I put there. Now, the power consumption become it's a big challenge to people, to maintain that. Because if I want to monitor my cow in the farm, I can't put a whole bottle of device and put it in my cow. Even if I put something in the collar, if it's in my location in another case, then for example, they will make the cow to move very close to them. They will take that thing, take it away, and take cow to another direction. Your device will go north, the cow will go south. But if you do any device, like you put it in their anus, you plug it in their whatever. Now, I understand, okay. I'm also get scared of animal cruelty. But all of you keep chewing meat. And you cry for animals, We had one of our friends who came from Germany for Christmas, and I took that friend of mine to my farm. And I bought 2 sheep to slaughter for Christmas. When I lied down the sheep to slaughter, she came out. She asked me, "Pius, what do you want to do?" I said, "I want to kill this sheep." Then she started crying. I thought that, oh my God, she started doing that. Then I said, okay, what can I do now? Because I need to kill the second one anyway. Then I took the second one to the backyard. to go and kill. Now, somebody that is crying for the sheep that is being killed, what do you expect? When it's roasted, what do you expect? Not to eat. I thought she won't eat. When we finish the bride, can I have a bite? One bite. Can I have that? Then I said, but now I don't understand it. I said, the same sheep we kill there, that's the one you are eating now. Saying I can eat, but I don't like killing them. Okay, that's fine. How do you get them into your pot? Okay, now one of the problem is basically the power consumption problem. Now, not only that, we also think about the energy harvesting. Energy harvesting in the sense that if I have a device that I put on sharks, for example, when it's going through the oceans or whatever, remember, it will come out and then go back. Maybe we can create some small solar cells that are very sensitive to take some energy and charge the battery. Therefore, that is where the energy harvesting comes from. Do you get it now? Or during the mating, for example, they generate so much heat. You can tap into that heat and use it to energize the battery, possibly. Yeah, you see. Then the other area is to look at the area of the optimization of it. In other words, when I put my sensor in this item, I put my sensor here. The battery here is low, but the battery here is high. They should transmit the energy to empower this to make it continue doing the measurement. Whereas this one can just do that. Therefore, you look at that on the area of optimization. The other area is to look at what we call a self-defined network, which also is very, very needed in terms of the clouding, the routing, basically by using the self-defined network to take place, and you have them as a base of the IoT. Then the standardization, which is more of the humanity area of specialization. I don't expect you to do anything here. You are wasting the degree. Therefore, don't do anything in the area of standardization because that is not your interest. It's meant for humanity people who deal with policy, people who write all those things. They can do something like that in that area so that they look at the standardization for interoperability, heterogeneity of a sensor. But if you are informatics, perhaps, but that is not what informatics is all about. But if you want to dodge the degree, you can just go there and dodge the degree. But there is not much to really do in terms of a physical stuff. It's just about more of writing, collecting data. Ask this guy, did you eat today? Did you sleep 2 o'clock? When did you wake up? Then you begin to write that. Then you take that and do whatever, you know. If you want to do that, then that's the area. But it's not the core of the business that you have there. Okay. Now, I think I'm getting to the end. I think I've talked too much. Now, I'm not sure if they say I should give you assignment. There's no assignment. No, I need to hear from you. If I have to give you assignment, you have to say it now. No. Oh, okay, there's no assignment. There was a man who came also before me. He didn't give you any assignment. No. Okay, once he didn't do that, I won't do that as well.
Specialize in that field.
Oh, okay.
Yeah.
And you don't want to specialize in this field?
We're still exploring.
Anyway, now do explore very well. And I think from our side, I don't know if you have questions that you want to ask me with regard to IoT.
Yeah.
I will definitely try to answer to my best knowledge.
When it comes to the research programs that you've discovered under the IoT,
yeah,
you can scale your ability managing massive devices,
yeah,
multiple devices. Do you have an idea of how you can do that management?
You see, there are two ways. There are many ways you can actually look at the scalability from the point. Is it that you are from informatics? Are you from IT?
Yeah, computer science.
Computer science. Look at the area of the optimization techniques. Optimization technique and resource management with respect to scalability. Okay. In other words, there are so many algorithms you can use when you want to manage the area of scalability. A very good example is what I've given you now, which is called resource management techniques and the optimization techniques to manage the scalability. Because I'll give you one example. If you have the IoT resources, remember that I shouldn't make some of my devices to be active because they are doing repetitive capturing of data. I only need a responsible data out of the one that I've captured. Now, the resource management techniques and the optimization will make you to make a choice. Out of this string of data I'm capturing, which one? Is it the one early in the morning, the one in the midnight, or the one by 12 o'clock? Now, you develop a resource management algorithm that does the picking of a responsible data set that you need to predict or to do some determinations. It's a big work. Then that's reduce the power consumptions of your resources. It conserves it for you to have a longer period to use that device. And that's a very big problem that we have with it. Because all the devices we have now, they just measure the data all through, either responsible data, useless data, passive data, active data. They just measure everything. Therefore, there's no need to have a data that is you just have data for data's sake. If you read your data string, you just see 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. Then before you see 3, it is 1 a.m. in the night. Now, what happened to all the 2s? You just waste the memory for nothing. Now, if you develop a resource management, he understands, he check the string of data that is coming, he stop them. He passive, he silent the system, not to measure on the same data. Now, that conserves the energy of the device. And that comes from resource management and optimization techniques that you have to incorporate into the system design. But one thing you must understand with master's program is you must understand a master program is a master of someone concept. PhD is a philosophy of 3 things that must happen with PhD, that you will say someone has PhD. 1, you must either against somebody. You must either innovate, you must not support. Then it's not PhD. If you support my model, you only do masters. If you improve on my model, if you innovate new idea on my model, if you innovate, then you will be given the award of philosopher. Because PhD is philosophy. Oh, why do we come to office working this way? We always come like this. Good morning, everybody. What's wrong with this? Good morning, everyone. Good morning, everyone. Good morning, everyone. Now, you do that, then you prove the philosophy around it. You say everybody should be walking backward, using the back to walk. Then you prove it. It doesn't mean it's right or wrong, but you prove the knowledge out of that reasoning. Then it becomes PhD. It's a master because you look at my work and say, I want to master this guy's work. Then you take it. Then you begin to work on it. Then you're able to replicate my concept. Then you might put a little bit better things on it. Then it's a master. That's why they call it a master. It's a master of a concept. You master somebody's concept. That means when you read paper within the domain of that knowledge. No one say extrapolate a new knowledge from that. Then it becomes philosophy. Because now this guy is drinking water this way. You say, no, drink this way. Then you make a proof why he should drink this way. Like medical people, what they get PhD on is to say that we should be eating lizard because it has protein. Then they test the protein and say this protein is missing. Start eating the lizard. Yes. Then you start cleaning the lizard and start eating. Then it becomes PhD because now you philosophize. And that is why when you get a degree of PhD, if they give you Zulu to read, you understand because it's a philosophy. The key of philosophy is on you. If you take me now to go and study law, I should enjoy it because the philosophy will carry me through. And which means I always pass the law school every time with less energy. Anyway, all the administrative law, all those commercial law, I enjoy them. Constitutional law, I enjoy them. But what I'm saying is that it just builds your brain to be able to philosophize. When somebody look at something and say, it's red, this thing is black. But it's red. But you now say, okay, look at the inside of that shirt, there's a red reflected in. Then you philosophize. Then become philosophy, And that is why when you write a paper on a topic today, by tomorrow a new idea on the same subject matter, you now say, this reason is not accurate. And that's why they take your paper. And because you keep involving new thought on the subject matter. And that's it. That's how it is. Therefore, that's the difference between the two. Therefore, the outcome one expects from you as a master is your ability to be able to master a concept clearly and be in control of that concept. But ability now for you to philosophize is your PhD. It's an abstract word. When you look at something, you are not actually looking at it. You are looking at the back of that thing with abstract word. That is why if your wife is a PhD holder and the husband is a PhD holder, they will never be romantic till they will die. Because they will be reasoning thing. Because the sense of reasoning will be this way, while this one is reasoning that way. Therefore, they will never collide. It's never be the same. And that is why you see average professor, they divorce at the end of the day. Because the reason is too much. Yeah, because they reason too much all the time. It's only rare for them to come down in thinking. You see, it's very, very rare to see them, to come down in their normal way of thinking, And that's why you see them with so many problems. One, we have so much money, we'll be riding bicycle from home here. His hair will be like this, like there's no barber around to barb the head. The hair will grow, the beards will be like this, like there's no clipper to, come on. But that's what they do anyway, in principle. And because they think too much. They even think when they get to the mall. Have you ever seen Professor when he carry the Coke? Shake it out, okay. How many liters? Okay. Just go, 12 rand.
Is that what you do?
I don't think I do that anyway. But to really welcome you to the world of masters and PhD, I think it's a very good thing. Apart from you adding value to yourself, you had more thinking strength to your thinking capacity, and it's always beautiful when you have power to think and to be able to see things in a different way that people have never observed before. Because once people said when you have PhD, it's permanent head damage, but it's wrong. PhD, permanent head damage. Have you ever heard that? But at times it is, at times it's not. You see? But the issue there is that it extrapolates your mind to see things that people have never seen before. Because it's an abstract word. And your mind have to journey out of you to that word to see something that's very new. One of my most celebrated papers in the world, and people ask me, how do I get around that? The problem is that if I tell people where I got the idea from, they won't even read that paper anymore. It was in the toilet. Early in the morning, I was sitting down, and the concept flowed through me. I said, oh. Now, they have one student now working on it in Cambridge University. Then I say, if I tell this guy the story about this thing, he won't even think of, this thing comes from a rubbish zone. Let's throw it away. But that is the why how the mind always work. Because it's an abstract word, and it's an abstract journey. The mind travel there, it takes information from where people mind has never traveled to, before. And that is the purpose that when you begin to do master and PhD, you want to bring things that in a different place back closer to people and explain to people what is there. That's how your mind, it's going to work. And it's very beautiful. It's very beautiful. If you start exploiting things, you will find out that you just enjoy it. When somebody is talking to you, you can imagine before he finishes his word, you know what he's going to say. Yeah, you know exactly what he's going to say. And from there, you tend to be looking like a Shangoma. You know, because you can basically perceive or based on the knowledge. Because the power of knowledge growth has a power to be able to bring things that is far from mind to fetch back very close to you. Yeah, that's the power of the mind. You know, therefore enjoy it and explore it, but enjoy it in something that you love most. If you don't like something, don't go for that topic. You must love what you want to go for, you know, because you will be discouraged. You know, that inspiration will keep you alive to enjoy it. Like, you just want to, I want to know more, I want to know more. But if somebody, if you do something that you don't like, even if they give you the answer, you will miscopy the answer. If they say run simulation this way, you run it that way because you don't like it. Therefore, enjoy it. You know, try to take something that you feel it will benefit you. And lastly, let me tell you, don't do something that will never hurt to you. 2 years is a big years in anybody's life. 2 years of brain punishment, 2 years of not sleeping, 2 years of denying yourself something that other people enjoy. Now, why can't you use that 2 years for something fantastic? Something that you know that, okay, when I leave, okay, I'm going to be a data scientist, I can have my own company, I can be a data business analytic, okay, I'm going to gain these tools, I'm going to use these tools, I'm going to solve this problem. You take that with you, then you're going to be an expert in something. So that if something will end up in thesis, I don't encourage African kids to take that thing anymore. If something is going to end in thesis we keep in the library, it's a waste of time. Therefore, do something that you can live on. Something you can say, I will have my small scale company around it. I will consult for people to solve this particular problem. I will do this. Then you are investing your time in the right directions. You know. Therefore, think about all those things, you know, that will help you. Also, try to think beyond where you are. Where in the sense that when you know the scope of the topic you want to take, you have 3 weapons that must be with you. You have yourself, you have the materials. You must make sure that you have the materials near you. Then you have supervisor. You see, if you have good supervisor, even if you don't know, it will help you. It will lead you. If you have bad supervisor, but you have good reference paper and you have yourself, you will escape, but you will fight. Because if you tell me what is not within my thinking, I'll say you are doing rubbish. Go and do it again. It must be within my thinking to say yes. To say, okay, oh, your thinking is okay. Therefore, you must balance the rhythms. You know, balance it in the sense that you know there is a skill with him. I have a skill to search. I have resources with me. Now, when you combine the 3 together, you will finish on time. But if one of the elements is missing, you will have a little bit issues, you know, along the line. Those are things that you must, don't say you want to go to the moon this year. You will never get there. That's a big topic. Leave it for America to go to the moon. Go to Kwamasho Omlase.